overnight. I will end on that question. So, my energy for communicating science derives from the research that I do. The research, for me, is thrilling. The press reports the results of research, which for some projects can take many, many years. So if you want to become a scientist, you have to learn to love the questions just as much as the answer, because in fact, in some cases, you don't even get to an answer. You find out you're navigating the wrong path. So the people who say, oh, graduate school is a pay, I can't, that is science. What you're doing as a graduate student is becoming a research scientist, and that's what you do. You work long hours, you're in the lab, you occasionally forego personal hygiene. You know, this is what that is, okay? I bet you Darwin and Newton did not smell very good, all right, is my guess, okay? Newton, while he is discovering calculus, all right, he's probably not saying, oh, I need a shower about now. No, he's pretty focused doing what he's doing, all right? And so that's where I derive my energy to share the passion. Now, I would do so no matter what, but there's a more important reason for doing it, and that is most pure research in the sciences that goes on in America today that's not product-driven goes on at universities, and the source of those monies are from public-based, tax-based funding agencies. So, collectively, we pay taxes to the country's portfolio of spending, some of which funds the science that's conducted by scientists. As a result, the science that's done, the scientist that conducts the research, is obligated to the public to share with them the fruits of their research. The public paid for it. And I submit to you that there was an era before that was taken seriously. There was an era where the scientists in the lab would say, the press is beneath me, they'll probably get my story wrong, I don't want to have anything to do with them, leave me alone. That happened only to the peril of the funding stream that went into those labs. And the first person to realize this in a big way was, in fact, Carl Sagan. Because what happened was, he would start bringing science to the public. He did it sort of first and best. And colleagues said, what, you're on the Tonight Show? You're a scientist, and you'd stoop to go on the Tonight, and he was criticized for this, criticized. Meanwhile, the scientific community saw their budgets rise. And so in astrophysics, we learned earlier than in other fields, the value, the general value of bringing the fruits of our research to the public. And I can tell you that, I don't know if I'm biased, probably I am, but maybe a little bit is not. I think Hubble images are pretty cool. I think these pictures I showed you tonight are kind of awesome. I think all of us, at some point, we look up and wonder what our place is in this universe. And a small fraction of the total population gets to actually call that their career. So at no time do I take it for granted that it is not only a privilege to study the universe, it's an honor to do so with the sanction of those who are taxpayers and who even come out and hear a lecture that I give. Thank you all again. Seattle. You look at the chemical ingredients of life itself. Put them in order. In rank order. You get hydrogen, which comes from the water molecule. You get oxygen, which comes from the water molecule. You get carbon. It's the foundation of our chemistry. You get nitrogen. In order. And the next one is the most famous element of them all. It's on every single list. It's called other. Okay, so hydrogen, oxygen, carbon, nitrogen, other. Now you go, that's in life. Now let's turn to the universe and say, hey, universe, what do you have ranked among your elements? What's number one for you? Hydrogen. What's number two? Helium. Well, if you remember from chemistry class, helium is inert. You couldn't do anything with it chemically even if you tried. So let's skip that. Next in the universe, oxygen, carbon, nitrogen, other, thank you. So, we are one for one the same ingredients in the universe, which itself is a bit humbling. If we were made of an isotope of bismuth, then you'd have an argument. You say, hey, we're rare stuff. Come here, check us out. Look at where we are, all right? But like, no, we're made of the most common ingredients of the universe. But those ingredients are traceable to the actions of high-mass stars that forge these elements in their core, destabilized, exploded, spread their enriched ingredients, their guts, across the galaxy, creating environments where the next generation of stars will have the ingredients that can then make planets and people. And so, not only are we in this universe, the universe is in us. And I know of no more enlightening, ennobling, enriching thought than that. And that is the thought I'll leave you with this evening. Thank you for your attention. So now you bring your insights to those first few moments of the universe and say, what must have happened then, given what we know goes on in our particle accelerators? And it will tell you, at the rate we were expanding, at those temperatures, you would be making hydrogen as the predominant atom in the universe. It's the simplest atom. It has only one proton in the nucleus. You make this much hydrogen. You make this much helium that has two protons in the nucleus. You'll make trace amount of lithium. That's the third element on the periodic table of elements we remember from chemistry class. And nothing else. We will be a universe born with hydrogen and helium and barely any lithium. Wait a minute. And you say, if that's so, it would mean that the very oldest stars we can find, ones born closest to the Big Bang, that would still be alive today, would be comprised of only hydrogen and helium. That is exactly what we measure. The very oldest stars have the least amount of heavier elements, which we know this from the mid-20th century, from calculations enabled by the nuclear research from the Manhattan Project and the atomic bomb, because we're calculating what atoms do. We know that after that time, stars are born, pure hydrogen and helium, they manufacture heavy elements in their core. Then some of them explode, scattering this enrichment to gas clouds that have yet to form stars. Now they form a next generation of stars that have a little bit of extra enrichment. They'll make even more enrichment, explode, and then carry that extra enrichment to the next generation. And this continues through. Our solar system, was born 4.5 billion years ago. So that's more than 9 billion years after the start of the universe. So we've had the benefit of multiple generations of enrichment. So now when our protocloud collapsed to make the sun, it had all these other ingredients in it that it used to make planets. Because rocks are not made of hydrogen. They're not made of helium. They're made of silicon and oxygen and aluminum and arsenic, all these other iron, cobalt, nickel, all of that manufactured later is in abundance in very late generation stars that were formed. So the lesson here is, however weird it is to assert that 14 billion years ago the universe was this big, literally this big, and exploded from there. You say, well, you weren't there, how do you know? Okay, you're right, I wasn't there. But if everything we know happens to matter, happened then it accurately predicts things we do measure. That's what gives us the confidence to sit here and describe the first 10 seconds of the universe like we were there. How old are you?
How old are you? How old are you?
6 3/4.
Love those fractions. Yes, yeah, you know. Okay, if you're asking those questions now, you'll be the deepest thinking adult there ever was. So what is the meaning of life? I think people ask that question on the assumption that meaning is something you could look for, and then, oh, I found it. Here's the meaning. Here's what it is. I've been looking for it. Okay? And it doesn't consider the possibility that maybe meaning in life is something that you create. You manufacture for yourself and for others. And so when I think of meaning in life, I ask, have I learned something today that I didn't know yesterday? Bringing me a little closer to knowing all that can be known in the universe. Just a little closer. However far away all the knowledge sits, I'm a little closer. If I live a day and I don't know a little more that day than the day before, I think I wasted that day. So the people who at the end of the school year say, this summer I don't have to think anymore. I'm thinking, what? To learn is to become closer to nature. And to learn how things work gives you power to influence events. Gives you power to help people who may need it. Power to help yourselves, to shape a trajectory. So when I think of what is the meaning of life, to me that's not an eternal, unanswerable question. To me, that is in arm's reach of me every day. And so for you, at age 6 3/4, may I suggest that for you, you should explore nature as much as you possibly can. And occasionally that means getting your clothes dirty because you might want to jump into puddles and your parents don't want you to do that. You tell them that I gave you permission to jump into puddles. Okay? You know what else? You know what else? So, I'll give you more permission for more things. You ready? Okay. Have you ever pulled all the pots and pans out of the cabinet before and hit them with the wooden spoon? Have you done that yet? Have you done that?
In a way.
He said, in a way. And what did your parents say when you did that?
Well, I did it with paper plates, but...
Oh, you did it with paper plates. That's not nearly as fun as doing it with the pots and pans. Okay? So you have my permission to pull pots and pans out of the cabinets and bang on them with spoons and knives and things. Not knives. Spoons. Okay. So, here's the thing. You're still a kid. And part of being a kid is exploring the world around you. And all the way the laws of nature influence that world. So take different pots and pans and hit them with a spoon, and they'll all sound different. They'll sound different with different spoons. Some pans are aluminum, some are steel, some are copper. They'll sound different, and that's kind of a fun experiment. And most parents will say, don't do that, you're getting them dirty. Stop doing that, you're making too much noise. You tell them, then why did you have me in the first place? Okay? Just to remind them that they didn't have kids so that they could keep having a neat house, okay? Because kids make things messy. And there's a reason why they make things messy, because they're exploring the world around them. And so you have my permission. Now, if you get in trouble, I'm not going to be around. I'm going to be back. But we have witnesses here, right? Okay, so your meaning in life will be enhanced if you're given as much freedom as you can to explore the world. Then when you get older, you will become so close to how the world works that when a problem arises that needs a solution, you will say, I know how to solve that. I've been thinking about that before. And I've been thinking about that ever since I was banging the pans on the kitchen floor, or ever since I jumped with 2 feet into a puddle, or ever since I walked up and down and caught snowflakes in my mouth as I walked down the street. Did you do that today when it snowed? When was the last time you caught snowflakes in your mouth?
Like a few weeks ago.
Okay. Okay, I'm gonna ask a grown-up that same question, okay? When was the last time you caught snowflakes in your mouth? I don't remember. You see the problem here, okay? The grown-ups have forgotten how to embrace nature, how to think about the natural world. So, you will owe it to yourself and everyone else who will be cured by some medicine you may invent one day. You owe it to yourself and to everyone else to continue to stay curious. And by doing so, you will have created the meaning in life that others think is waiting under a rock for them one day, and you would have made it happen all on your own. So thanks for your question.
Let's look at the cosmic abundance of elements. In the universe, the number one element is hydrogen. Next, helium. Next, oxygen. This is in order of abundance. Next, carbon. Next, nitrogen. Next, perhaps the most important element of them all, you see it in most lists, other. Yeah, there we go. Now, what about life on Earth? Let's see, what's the number one element in life on Earth? Hydrogen. Well, how does that happen? Well, because, as we know, at least, human life, you learn in biology class, is mostly water. And water is H2O. H2O. The H2. H is hydrogen. Okay? How about next? Oh, no, not helium. Why not helium? Well, because helium is noble. We learned that earlier this evening, didn't we? So helium is not in us. You can inhale it. You sound like Mickey Mouse, but it won't interact with us. So even if it were available to us, there's nothing you would do with it. So it's in the universe, but not in life because it's not chemically active. What's next? Oxygen. Next, carbon. Next, nitrogen. Next, together, other. Life on Earth is one for one, in sequence, made of the most common ingredients in the universe. And we are chemically based on carbon. We are carbon-based life. Why? It turns out that carbon is the most fertile element there is. You can make more kinds of molecules using carbon than all other kinds of molecules combined. So whatever chemical experiments are going on the surfaces of planets across the galaxy, if we find life anytime soon or ever, the chances are good that it's going to have carbon as its base, as its chemical base. And you combine all these elements in all kinds of interesting ways. Science fiction stories like talking about silicon-based life. Silicon sits directly below carbon on the periodic table, which means they bind similarly to the same other atoms. The problem is carbon is 5 times as abundant as silicon. You don't need silicon to make this work. Carbon is there for you. Now,
in the expanding universe, we are told, and I have to believe it, that everywhere is, as it were, the same as everywhere else. There's no one place which is the edge of the universe. How can that be?
Well, Richard, first of all, you said you're told it, so you have to believe it. I will never require you to believe anything.
Good for you. Well done.
It will only ever be about how compelling is the evidence to you. We look around the universe and it looks like we're in the center. What an ego-supporting concept that is. You can either go around continuing to think that, feeling good about yourself, or study the problem and learn that in an expanding universe where the speed of light is finite at 186,000 miles per second. Forgive me using miles per second.
I prefer miles.
You do? You got that on tape. You're an Oxford professor.
No, it's true. Nobody talks about kilometers in Britain.
Oh, good. All right. So we share not only most of our language, we share miles still. And inchworms, what do they call them? They're not centimeter worms, right? They're inchworms.
We don't have that sort of stuff in Britain. That's Europe.
Of course, Britain is not Europe, as we're constantly reminded. That's why here we have the English breakfast and the continental breakfast.
Yes,
they're very different breakfasts that you can order here. So this horizon problem is actually quite simple. And rather than explain the full-up nature of it, let me just give a simple example that is entirely analogous. When you're a ship at sea and you look out, your horizon in every direction is the same distance from you. Depends on your height above the sea level. That's why ship decks are high. They see farther beyond the curvature of the earth than you do just standing on the main deck. So your horizon is a perfect circle centered on you. You can conclude that is the extent of the entire earth, or you can imagine, suppose I'm in another spot. Well, that horizon is still true for whoever happens to be in the middle of it, but now you've moved to a new place, and you will see a horizon corresponding with that spot. And so everybody has a horizon at sea, yet no one at any time is thinking that that's the full extent of the ocean or the full extent of the earth. We have a horizon in the universe, so does the Andromeda galaxy. The galaxies with names that look like phone numbers. We've got, if you travel to those galaxies, they will see the edge of the universe now in 3 dimensions, in every direction, at the same distance from them, just as we see for ourselves.
That does it for me, provided that the horizon is that which we are capable of seeing. I could follow that if you said that for any part of the universe, the horizon is the bit before the expanding universe has disappeared over the horizon.
Yes.
Which means it's no longer visible.
Yes.
No longer, but it's still there, even though we can't detect it.
It's true with the ocean when you're at sea.
Yeah, but is anybody on my side here?
You want it to be a harder problem than it is. I'm just simply saying, so here you go. Here you go. The radius to our horizon is about 14 billion light years.
Got it, okay.
Okay?
Yeah.
If we sat here, or returned to this spot 1 billion years from now, that horizon will be 15 billion light years away.
Yep.
It's actually an expanding horizon because the light from 15 billion light years away, will have had time to reach us. Right now, it's still en route.
Yeah, I have no problem with that, but beyond the 14 billion year...
The problem is the universe wasn't born yet.
Yeah, okay.
That's the problem.
I know.
Okay? So you can't see the universe before it existed.
So why doesn't somebody...
Invent a kind of telescope that can?
No. Okay, I'm getting out of my depth here. Let's get back to...
No, just to clarify.
Okay.
Just to clarify. So it takes light time to reach us, and the universe hasn't been here forever. When you combine those two facts, you get an edge of the universe. And so the universe has been here for 14 billion years. The farthest thing that could send us any information is 14 billion light years away.
I get that, but what about the guys who are on the edge of what we can see? How can they see beyond the other side?
Oh, because here's an interesting point. We don't know whether or not the entire universe is infinite.
Okay.
And our horizon is, the universe could be twice our horizon or infinitely larger than our horizon. Same with the ocean. You don't know how much bigger the ocean is than your horizon is. You can keep sort of wandering around. Maybe you'll hit land, as we've done, of course. So now you go there. If the universe is really, really big, that will be the center of their own horizon. And whatever the age of the universe is for them at that time, that will be the radius to their horizon.
Yeah, okay.
Anyhow, this object, which is moving in these 4 frames against the background, is the first ever icy body discovered outside of Neptune. Actually, it's the second ever icy body discovered outside of Neptune, the first being Pluto. This is a new swath of real estate discovered with this image, and we name it after the fellow who proposed its existence, Gerard Kuiper. It's the Kuiper belt of icy bodies, a Kuiper belt of comets. The number of objects now known is in the thousands, all discovered in the last 20 years. And some of them have orbital properties that greatly resemble that of Pluto. The same orbital tilt, they look and smell like Pluto. So those have been collectively called Plutinos. That's kind of cute. So Pluto has brethren out there. And this is what we knew in the year 2000. Pluto and they look more alike than either they or Pluto look like any of the other 8 planets. And we figured, hey, it's time for Pluto to own up to its actual identity. Because when it was alone, you can't make a class of 1. That doesn't work in science. So we said, okay, Pluto, we'll grandfather you in. Okay, we'll call you a planet. We don't know what else to call you. Okay, now it's got family. The Kuiper belt. There you have it. And I think Pluto's happier there. Okay? Really? Do you know that our moon is 5 times the mass of Pluto? Any Pluto lovers out there who didn't know that? See, that's kind of sets it straight for you right there. Do you know if Pluto were where Earth is right now, its ice content would evaporate and it would grow a tail? No, that's just embarrassing. You can't have a tail and call yourself a planet.
Well, really up till the year 1600, when we didn't have any particular tools to investigate the natural world, our 5 senses were the primary means by which we obtained all information about the universe. And not even knowing that our 5 senses had limits. If it's everything you know, you think it's everything the universe is trying to give you, but in fact it's not. And so around 1600 was the invention of the microscope in one direction, and then the telescope in the other direction, each invented within a decade of one another. Then all of a sudden, pieces of the universe come available to us that transcend our senses. The fact that Leeuwenhoek would look inside of a drop of pond water and see microorganisms just like doing the backstroke, right? That your eye-brain sensory system could not have detected were it not for the microscope. And, you can say, does that make sense? That you could have entire living creatures inside of a drop of water. Well, today we know that because we learn it from childhood, but in the day, it made no sense at all. In fact, he had communication with the Royal Academy, Royal Society in London, which is what you would normally do when you make a discovery. And they thought he was drinking too much gin. It's like, write another letter when you've recovered from this stupor, from this drunken stupor, and then we can continue our scientific conversation. So they were in denial of it until they sent someone up to verify, which is a very natural thing to happen among scientists. One eyewitness testimony about one result is not a scientific discovery. You need verification of it to confirm that it's real. And especially in modern times, the 20th century and onward, we have particle accelerators. We discovered quantum physics, which has rules of how matter behaves that fall completely outside of not only your senses, but our expectations for how life would, how anything should work. particles popping in and out of existence, matter turning into energy and back and forth. So then we discover like black holes and the expanding universe. How could everything there is be expanding at all, right? And so if you keep invoking, that doesn't make sense, you're going to miss out on a lot of what we have learned, discovered to be true about this universe.